Okay, this is Math 2, and we're going to do 7 to 10 in this video. The first one says a regular hexagonal prism has a volume of 2546.13 centimeters cubed. So if you, oopsie, that was a loud noise. But just to remind you what the hexagonal prism is going to look like. Well, I broke this one apart, but it looks something like this, where you have two bases, right? That's why we call it a prism. And then you have 1, 2, 3, 4, 5, 6 lateral faces. And if you break this apart and to find the area of all the pieces, you have the surface area. And if you find the area of your base, you should be able to multiply by the height, you should be able to get your volume. So again, volume was find the area of the base and then multiply by how tall it is. That should give you the volume. So in this case, we have the volume is equal to area of the base multiplied by the height. Well, we don't know what the height is, but in this problem it does tell us that 14 is actually the edge of the base. So 14 is actually this little piece right here, which is actually in this picture right there. So please pause the video and actually copy down the drawings first, because we're going to be working off of these. So we have 14, and we're going to find the area of the hexagon, right? And then that gives us this piece right here. And then we know that this is going to be 6 minus 2 times 180, so that's 4 times 180, which gives us it gives us, is it 720, I think? Divided by 6, you get 120, and then divide that by 2, 120 divided by 2 is 60, so that means you have 60 degrees in here, and since the base is 14, we can cut this in half, right? That'll be 7 and 7, which is what they have here. So this is a 60-degree angle. 7 is your base of this right triangle. You need to find the height. The height of it is going to be a tangent function. So tangent of 60 degrees is going to equal opposite over adjacent, so x over 7. So tangent of 60, I cannot remember my tangents well. I remember sine and cosine, just not tangents. Where's my calculator? 60 tangent. Okay, 1.73. Okay. 1.73, let's say 1.732 over 1 equals x over 7. So multiply that by 7. You get your value of your height is 12.124. Okay, so x is 12.124. So let's back up now. Area of this triangle up here, since x was 12.124, area of your triangle is going to be base 14, not 7. 14 times the height. 14 times 12.124 divided by 2. So 12.124 times 7 is going to give me an area of one triangle is going to be 84.870. Well, let's just say 84.871. And then area of the whole hexagon, take that amount, multiply by 6. So times 6 is going to give us an area on the hexagon of 509.223. Okay, 509.223. So area of the base, in this case our hexagon, is going to be 509.223. We know the volume, and then we need to multiply it by the height. The volume is this much right here, so 2546.13 is going to equal to 509.223 times the height of your actual prism, right? Because if we find the height The height is going to be how tall the whole prism is. So divide that and find the height. Okay, that's your height. Now, it says what's the surface area. So the surface area was, well, if you break apart your prism, your surface area was what you see on the outside. Well, what you see are two hexagons. You know the area of one of them is 509.223. The area of the other one is 509.223. Add those up. And then once you find the height, right, this is going to be 14 by whatever your height is. So 14 by whatever this is. Add that up 6 times or just multiply by 6 and add up this rectangular piece on the area plus your 2 and you should be fine with your surface area. Please don't forget that your surface area is units squared. So in case we have centimeters here, your surface area is going to be centimeters squared. Okay, number 8. In the diagram at the right, DE is a mid-segment. Okay, so that means it cuts those pieces in half. If the area of ABC, the whole thing, is 96 square units, what's the area of ADE? Oh, so this is going to be, so these are the same, right? Okay, so one is going to be half of the other, linear-wise, but the area is going to be to the 4th power. Okay, so 96 divided by 4. Yep. Okay, so 96 linear. I shouldn't say that. The linear ratio is going to be a 1 to 2, right? Because you take it and you're going to double it up. The area ratio is going to be 1 to 4 because 1 squared is 1, 2 squared is 4. So the area of the small one times 4 is going to equal the area of the large one. Well, if you know the large one has an area of 96, then you really just need to find the area of the small one. So 1 to 4 is your ratio. It has to equal to something, the area of the small one, over 96. So find x, and you have the area of the small triangle, or in this case you're looking for ADE. ADE. Okay, so find x. Alright, number 9. Well, this should be pretty easy to do, I think. Hey, there's more of these. The circle at the right, CD is the diameter. Okay, that helps, because then we know if we cut it in half, it's going to give us a radius. AE is 10. Okay, so AE is 10. CE is 4. AB, the whole thing is 16. Okay. Ooh. Okay, this is going to be a little weird, but that's okay. So it's looking for what is the length of the radius of the circle. So we really want to find CD, the whole thing. Okay, so I'm going to put what we know. So if the whole thing is 16, that's 10. This part has to be 6 over here, right? So we know that 10 times 6, right? So 10 times 6, this length AB, has to be equal to, C 4 times something else. So 4 times, I don't know, I guess we can say x. E to D, we'll call that x. So 10 times 6 is going to have to equal 4 times x. Okay. So it's going to equal 4 times x, right? That'll be this length right here, the whole thing. Okay, so let's see if this makes sense. So that's 60 equals 4x. That means x has to be equal to whatever 60 divided by 4 is. 15. Okay. So x is 15. So that gives us that the whole blue segment from C to D is actually equal to 4 plus the 15. So that part's x. So 4 and 15 together is going to give you 19, right? So if the entire diameter is 19, how much is your radius? That's the question you need to answer. And then the last one, figure at the right shows two concentric circles. That just means one circle is inside another circle. What is the relationship between AB and CD? How can AB be mapped onto CD using a transformation? Okay, so they're both part of the same central angle. So AB over here is going to have the same measure as CD over here. So, I don't know, I'm just going to say, let's say APB is, I don't know, 50 degrees out in central angle. That means A to B is going to be 50 degrees also. C to D is going to be 50 degrees also. They're all going to be 50 degrees because this angle in here is your central angle. So how can ACD be mapped from AB is you would just dilate the circle. So in this case, you know, you just take the smallest circle, you make it bigger, and you get the bigger circle, which is actually what this part over here says. Dilate AB from P to get CD as your arc. And then it says, which has the greatest measure, AB or CD? Okay, the measure is the same, obviously, right? Now, the length is going to be different. So it all depends on your radius. So if you have a radius, let's say for the little circle, that's 3, and then the whole thing, the big circle, the whole radius is, I don't know, like 7, right? Then the length of it, if you have a small size pizza versus a large size pizza, the crust over here, even though you have the same angle on their slice, the crust is obviously going to be larger on the big one than obviously the small one. Okay, it all depends on what your radius is. And then it says if measure of angle P is 60 degrees and PD, which is the radius right here, is 14, what's the length of CD? Okay, so this case, I'm going to draw a circle really quickly just so we can write on it. Okay, so this case is 14, so this is P, this is D, this is C. And it says, what's the length of CD? So you want to find the crust, right? So the crust is going to be part of your circumference. So the circumference of the entire circle is going to be 2 pi times your radius, so that's going to be 28 pi. Okay, well, you have a 50 degree angle here. Oh, I'm sorry, 60 degrees. Sorry, not 50. I said 60. So in a circle, 360 divided by 60 gives you, well, 6 slices. You can have 6 total slices if each slice is 60 degrees apiece. So if I take 28 pi and I divide by 6 slices, that should give you the length of the crust. All right, so you figure out what that is. Use your calculator. Okay, and that was up to 10, and then we'll do the rest of them on the other video.